I'm not nervous anymore. Hello, everyone. So this is team at the Minions, and we'll be presenting our project Imagematics for our Sprint 1. And let's introduce our team member one by one. Start with Vaishnavi.
Hello everyone, this is Vaishnavi.
Hi, this is Christiana from Mission Learning team.
Hi, this is Deepika from Mission Learning team.
Hello everyone, this is Grishma.
Hello everyone, this is Yusong Hu from backend team.
Hello, everyone. So this is Ling Yiluan and from backend team.
Hello everyone, I'm Yash from front-end team.
Hi, this is Ramesh Ahmad from front-end part.
So our project description. So our project is basically we built a tumor classification system. So both patients and doctors they can use this system to reduce their diagnose time and increase their diagnose accuracy. And let's go into the next slide. And this is our team working agreement. We go through this last time, and we have three persons. The first one is a doctor, a radiologist, and the second one is a general practitioner, and the third one is a healthcare director. And for our MVP, yes, so we our system basically have six core features, and we are developing a two-step image analysis process that classifies medical images and provides automated diagnosis for both lung X-rays and brain MRIs. So this unified platform eliminates the need for separate diagnostic tools, increasing efficiency in maybe in clinical settings. And also for medical professionals, we are creating a user-friendly interface with simple upload functionality and intuitive result displays. So the performance is a key concern. Our system ensures accuracy through AI-driven predictions while delivering faster diagnosis to reduce manual analysis time. And finally, our basic report generations provides preliminary diagnostic information with confidence levels and suggested next. No, I think we're not going to do that. But yes, just provide information with confidence levels. So this MVP addresses the real clinical need for faster, more accurate preliminary screening of medical images, allowing radiologists and doctors to prioritize cases that need immediate attention. Yeah, this is basically for our MVP part. And this is our technologies we're using, like MongoDB, PyTorch, and we are also going to use AWS and etc. Yes, this is do we need to go like every slide of this
No,
or oh okay. So we've been go through this in our sprint 0 phase. So I think yes, let's just go direct to the yes architecture diagram. So all right.
Yes, you're on mute.
So in diagram illustrates the overall structure of a system, showing its components, their interaction, and the data flow between them. The user interacts with a web app, which acts as the main interface. The web coordinate between various components, such as AI classification modules, which process the image using the trained model. The AI classification modules return the diagnosis to web app, which displays the result to the user. The web app also store input data in the database for record keeping for future analysis. The second diagram is a context diagram. Can you change? Yep. So in the context diagram, this represents the system as a high level. focusing on how the system interacts with external entities like users, system, and AI model. The user uploads the image to the system. The system processes the image by sending it to the AI model, and the AI model processes the image and return the diagnosis, which the system relays back to the users. So next diagram is ER diagram. So mainly we have four entities: doctor, scan, patient, and report. And uh, we have in scan are performed on patients, and diagnoses are created for scans by users. So yeah, the next diagrams will Yupong present.
Yeah, the next is a sequence diagram. You can see there are four parts. The first one is user, and users can upload images to web app. Web app is the second part, and after processing, web app will return display diagnosis to user. And from web app to AI model, after web app receive those images, uh, the AI model will process those images and return diagnosis and finally return to the user. And from a web app, after process the images, get the diagnosis, the results, and web app can store those results in database. This is the four parts of a sequence diagram. Let's see the next one. The next one is just a simplified images. The to show the entire process. The first one is users upload images, and processing those AI model will process the images, and after processing, it will generate the diagnosis and the return diagnosis. Finally, return the diagnosis to the web app and finally to the users. And this is it. Next one. Yeah, next one is a class diagram. And there are several parts here. And let's go with the first one. Doctor radiologist. And it connects with the patient management module. And from this part, it will send the request to API gateway simplified. And after this one, and it will send a validates request to authentication service, and also to scan service. And let's see the next the second part is from the patient, and use the scan upload module, and it will uploads and scans also through the API gateway, and yeah. And the next part, another module is results visualization module. It will retrieve results from the let's see, give me one second. Yeah, from the API gateway, and from those three blue parts, especially the scan service, it will send images for analysts to the tuner classifier, and finally store those results into database. And the yeah, and after the results processor process the images, it will return processed results. And this is the entire process of the diagram. So
Yeah, so coming to product backlog. So first of all, the product backlog is a prioritized list of tasks and features that needs to be developed in future sprints. So like product backlog serves as a single source for everything that needs to be completed in our project. Uh, like we have included 3 sprints of tasks in this product backlog. You can see, and then if I go deeper, then Our backlog consists of user stories, tasks, and technical enhancements. So, like each item is prioritized based on importance, complexity, and dependence. And then, like for example, one of our top priority backlog items is like as a radiologist, I want an AI assisted diagnostic system to highlight abnormalities in X-ray images. So, like I can quickly identify the critical causes. So, another example is as a general practitioner, I want an AI model that provides an initial diagnosis with confidence scores. So, these are the example user stories. And coming to story points are nothing but the estimation, how much time is needed for to complete a user story. And then coming to acceptance criteria can be defined as a criteria that has been chosen uh, to say that the user story is done. If you see this thing as a user, I want an intuitive navigation menu. So I want a navigation menu to navigate to different sections of the website. So for this, the acceptance criteria will be implementing a navbar. So if you implement navbar only, the navigation is going to happen. So like this serves as the acceptance criteria. For every user story, we have written acceptance criteria, and for every story points, we have given sorry, for every user story, we have given story points. So, the product backlog will be continuously refined based on the feedback and sprint reviews. In each sprint, we tend to pick high priority items, define the story points and distribute work among team members. Um, and for the sprint one, our key backlog items were setting up front end structure in React and then implementing backend APIs for model communication, integrating AI model interface using Flask, and then creating initial UI prototype for medical image uploads, and then uh, uh, making the live application demo. We are trying to make an application demo, like UI part of the our project. So yeah, we have taken entirely 17 story points for this sprint one, in which we have completed 12. Uh, it's like around 70 percentage we have achieved. All these are like sprint 2 and sprint 3 user stories. This will be refined based on the feedback of sprint 1 and all.
Okay, coming to sprint one backlog, here we will be explaining the work done in this sprint. Coming to the user stories, firstly we have a user story for the landing page, and for that we have to include the headers, project description, CTA, and demo preview. And next, and the story points are given here, like 3. Next is navigation bar, which is used for accessing the website. For that, we have given the buttons like home, upload, results, and about. And next is image upload, where we have to upload images for all the medical. And there, for that, we have created file upload, where we used front end for that to upload the images. And next is responsive design, where we see that if the website is in responsive in all the devices, like mobile devices. For that, it has to add up the different screens in all the sizes. Next is static page. For that, we need to use the placeholder. Next is front-end framework and project structure. For that, we have to initialize the React project and configure routing. Next, implementation of UI components for buttons, inputs, and cards. For that, we have to ensure if it is reusable style components are available. And for all these user stories are mentioned, story points are mentioned. And next is sprint one text cases. For that, the text cases for landing page, expected result is like having all the project description, CTA button, demo preview, and we have got the result and we passed in it. And next is navigation bar link, where we have like different buttons, home, upload results, and we have achieved it, and so it got passed. And next is uploading images, where we upload all the images to preview the files that we have able to do in the next sprint. And next is like if we upload any of the PDFs or text other than images, then they displays the error image. So we also got passed in that. Next, like as I told, responsibility. UI layer should be adjusted properly. For that, we have passed. Like in the mobile device, also our website is responsible. Next, coming to static result page, we are able to work on the placeholders. Check if the React project runs. That we have passed, and it runs successfully with no errors. Verify button and input components. UI component should render correctly in all proper styles, and we are having that correctly done. Yeah, that's all.
For the sprint one, stories completed is all about that we completed several tasks with story points assigned to each. As Deepika explained in sprint one backlog, we created landing page with key elements like a header, project description, CTA button, and demo preview, which took 3 story points. We also developed an easy to use navigation menu to move between sections of the site, which took 2 story points. We made the website responsive, so it works well on both mobile and desktop devices, taking 2 story points. We set up the front end framework using React and made sure the site routing worked, which took 2 story points. In addition to that, we created UI components, which took 3 story points. And for the next slide, it's about sprint one stories not completed. There were 2 tasks we didn't finish in sprint one. The image upload interface was not completed because the image preview was not working correctly, which was assigned 3 story points. The static result, and the next one is static results page, which shows the diagnosis results wasn't finished because it needed some styling changes to match the design, which was assigned 2 story points. These tasks will worked on in the next sprint. And for the next slide, it's about metrics of our team performance. If we look at our team's performance, team velocity is the total amount of work completed in story points. And in sprint one, we finished 12 story points. The completed committed ratio compares the work we planned to the work we completed. We committed to 17 story points, but only finished 12 story points. So our ratio is about 70.59%. This shows that while we did a good amount of work, we still have a room to improve completing all our planned tasks in the future sprints. And burn down chart will explain by Ramesh.
Yeah, hey, the one-on chart visually represents our team progress by tracking the remaining workload. In sprint one, we committed 17 storylines but managed to complete 12 story points, giving us a completion ratio of 70%. Looking at this chart, we can see that while we made steady progress, we didn't complete all the planned tasks. And this could indicate some challenges or delay in the execution. The chart helps us identify these gaps and improve our planning for sprint 2 for ensuring better workload distribution and efficiency. And coming to the retrospective, so what went well is communication was very smooth between the teammates and most work have been finished as planned. And everyone contributed actively and there were no delays. And the progress is improved as planned to sprint 0. And team gained a clear understanding of this project and we have shared knowledge with each other. And what we need to improve is time management. Some are busy with their work, so we need to focus on time management. And there are some minor delays in the future. And we need to meet more online through Zoom meeting. Most of the time we work in WhatsApp chats, so we need to conduct Zoom meeting twice a day. And coming to the action items, we are breaking tasks into smaller tasks. So because of this, it is very easy to understand and we are setting up deadlines for task completion. And we have balanced workload and started working on the documentation.
And coming to the sprint two planning, So you can see we have some user stories here. If you look at story 6, it's about we need to enable image uploads in the future. And this is very critical because this is the entry point for all data in our system. And story 7 is about AI integration. So this is a core value proposition of our application. So we've assigned 8 score to this one. And comes to story 8, it's about displaying results clearly to users, which is very essential for us because we aim to build a user-friendly interface. And it is also very important for doctors and medical professionals to make decisions. And stories 9 and 10 is about the security, data security, and which is also very important because we need to protect sensitive medical data, and we'll be doing this with implementing user authentication. So comes to the next slide. It's also about we need to just implementing image uploading and also need to do refinement on our image preview and style issues, and also about the collaboration between the front end team and machine learning team and also back end team because for the backend team, we need to provide proper API endpoints. So for machine learning team and front end team, so we can work like seamlessly, which is with each other. Yeah, that's basically our plan for the next sprint. Yeah, then it comes to our website. All right.
Yes. So these are the screenshots which provides the overview of how our system works, from uploading the medical images to receiving an AI generated diagnostic results. So our goal was to create a clean, user friendly and efficient interface for the healthcare professionals. Next slide. So this will be our login page where these healthcare professionals can securely sign into their credentials. So we have implemented a simple and initiative design by entering the username and password. So even the new user registrations can ensure accessibility for all the users. So the next slide will be the dashboard. So this will be our dashboard. So once they logged in, users directed to the dashboard. Here they can quickly access recently analyzed images, patient reports, and system features. So the dashboard is designed to provide a clear overview of the most critical information, enabling the healthcare professionals to navigate the system efficiently. So the next slide shows how it is going to start. And next slide. So here, once the image is uploaded, the system automatically classifies whether it is a lung X-ray or a brain MRI. So this classification is the first step in our AI pipeline, ensuring that the correct machine learning model is applied for further analysis. So next we have the settings and user profile section. Here the users can manage their account details, or they can even adjust preferences and configure some notification settings for real-time updates on image analysis results. So coming to the next slide is the uploading the medical images. So we have the so the users can select and upload either the lung X-rays or the brain MRIs for AI-based analysis. So the system automatically detects which type of image and process it accordingly. So the after processing, the AI model generates diagnostic results. For lung X-rays, the system identify whether it is normal or it is viral pneumonia or bacterial pneumonia. So for the brain MRIs, it can detect the presence of whether it has tumor or no tumor. So each result includes a confidence score, providing doctors with an estimate of AI reliability. So coming to the conclusion, we support case tracking. Like we have implemented a patient history section, so doctors can search and filter the previously analyzed images based on their name, date, or diagnosis. This feature allows healthcare professionals to review past cases efficiently and track the patient's progress over time. Yes. So this will be our wiki page link.
Yeah, it's still the same one, right?
Yeah.
So
And
guys, now the meet time left for the meeting is 5 minutes, and the time is 11:52. So
11:52. Okay.
what do you guys say? Like, should I do a demo again, or should we just submit that one?
We can.
Because we only have 7 minutes to submit all the
But we
things.
have to upload this recording
Yeah, we
to
have to like
YouTube also, right?
YouTube.
Yeah.
Yeah,
Then we can stop here. We can submit them separately. Then it's okay, I guess.
it's fine,
Uh,
right?
Yeah,
Yeah, just
think
we
it's fine.
can put
Yeah.
the link over here, right?
Yes.
Yeah. So Lingy, you need to help me with all this stuff.
Yeah, sure.
Yeah.